Section 10.5 takes the gas laws and the ideal gas law, and we start kind of working with it and applying it to other areas. And with that, we can move the equation around to modify it to look at kind of the density of gases. And when you think of density, we're talking about mass related to volume. And so to start with, we've got PV equals nRT, and what we're going to do is we're going to divide both sides of the ideal gas equation by volume and by R and T. So we're kind of moving some variables around. So you end up getting N over V equals P over RT. And it might be worth your effort just to kind of take PV equals nRT and to do the operations just so you can kind of see how we get to this point, canceling out units as you go along, or variables. So next, we know that moles times molecular mass is equal to mass. So therefore, by multiplying both sides by the molecular mass, we get the relationship that of mass over volume is equal to pressure times the molar mass over RT. And this will then, now mass divided by volume is equal to density. So if you think of what we just had on that previous slide, and I'll go back here, so we had mass over volume. That is the equation for, or that's the formula for density. So now density is equal to pressure times the molar mass, or the molecular mass, over RT. One only needs to know the molecular mass, the pressure, and the temperature to calculate the density of a gas that might be present. So, yeah, which is kind of cool, actually, to think that it actually reduces how many variables we need to know to determine information about a gas that we might be working with. So we can manipulate the density equation to enable us to find the molecular mass. So let's say we want to find the molecular mass of a gas rather than determine its density. So if we know that density is equal to pressure times molecular mass over RT, we can move the variables around to figure out the molecular mass of a gas is equal to the density times R times T all over P. So these are just some ways to kind of move and manipulate the ideal gas law to find other information or useful aspects of gases that you are working with. So that's going to be it for today, and I will see you on Monday.